we will be looking at linear approximation. The meaning of linear means straight line. How to approximate the value of a function at a given point? Usually you think of it this way. If x is near to a, if x is about same as a, and fx is about same as fa. So is this a good approximation? Let's try out with some examples. The first example is you are going to look at square root of 101 and you approximate by square 100. You are using square root 100 to approximate square root 101. And because 101 and 100 are near, right? So we can say square root of 101 is about square root of 100, which is 10. If you work out the square root of 101, the exact value of square root of 101 is 10.04988. So with that you can calculate the error. So you'll find that the error is 0.5%. It's considered not so bad. And if you try to use 100 square to approximate 101 square, since 100 and 101 is near, 100 square is 10,000. If you work out 101 square, the actual answer is 10,201. So there's a difference of 201, and it's about 2%. So with that you see that the second example, the approximation is no good. And we are going to look at f prime a, how to use f prime a, and then how to use tangent line. How to use tangent line to approximate a function at function y over fx at x equal to a. In the beginning of the chapter, I mentioned f prime a is rate of change of the function y over fx at x equal to a. And we define f prime a to be limit x tends to a fx minus fa over x minus a. So we should expect if x is near to a, then f prime a and the fraction fx minus fa over x minus a, they are near. And then you can do cross multiply. So fx minus fa is about f prime a. You can multiply x minus a to the right hand side. So it will be x minus a. And after that you transfer fa to the right hand side. And you see this equation. Fx is about same as f prime a times x minus a plus fa. And this is actually equation of tangent line. If you look back to what we have learned earlier, you'll find this is an equation of tangent line. You can look at slide 57. Then you will find that equation of tangent line passing through a is y equal to f prime a times x minus a plus fa. So which means you can use tangent line to do approximation of the function fx at x equal to a. So you're going to use tangent line, and tangent line is a straight line. That's why you call it linear approximation. That's why I call it linear approximation, because we use straight line. Linear means straight line. So I have just mentioned that if x is near to a, then fx is about same as f prime a times x minus a plus fa, and it's actually tangent line. So if x is near to a, then the value of fx will be near to fa. And you can see from here, right? If you choose this point and you draw a tangent line, so you'll find that if you choose x near to a, so let's say at this point is a, fa. So if you choose point near to a, right, then the y value on the tangent line is about same as the y value on the curve fx. Let's look at 101 square again. This time we are going to use equation of tangent line, which is y equal to f prime a x minus a plus f a. So for 101 squared, to do approximation, you consider fx to be x squared, and you write x equal to 100. Differentiate x squared gives you 2x. So if you look at f prime 100, it will be 2 times 100, 200. And if you look at the equation of tangent line, f prime a is 200, right? Then x minus 100, because you choose a as 100. You look at a is 100, huh? Then plus fa, which is 100 square. And after that, to do approximation, you choose your x, right? Because 101. So it means you should sub x as 101. So this x is sub as 101. Huh? That's why here is 101. And you will find it work out to be 10,200. And just now we observed that 101 square is 10,201. So you will find that by using tangent line to do approximation, the approximation is good. The difference is only 1, 10,201 and 10,200. As for the other example, square root of 101, you should consider fx to be square root x, and you write x equal to 100. Differentiate square root x is same as differentiating x power half, which will give you half x power minus half after differentiating, which you can write it as 1 over 2 x power half, so it's 1 over 2 square root x. So if you sub x as 100, then it will be 1 over 2 square root 100, so it's 1 over 2 times 10. Square root 100 is 10, so it's 1 over 20, so it's 1 over 20, which is 0.05. So this time we choose fx to be square root x, and then you use equation of tangent line. So f prime a, right? F prime a is 0.05, and x minus 100 plus fa, which is square root of 100. And to approximate square root of 101, you should choose x to be 101. So you choose x to be 101. So that's why here sub 101. And this time you get 10.05. And remember, just now we observed that square root of 101 is 10.498, right? So the approximation is very good. So tangent line can be used to approximate square root of 101 with a good accuracy. Eh? So for fx equals square root x, dy dx is 1 over 2 square root x. So f prime a will be 1 over 2 square root a. And if you write down the equation of tangent line, it should be 1 over 2 square root a x minus a plus square root a. Y equal to f prime a x minus a plus f a. F prime a is 1 over 2 square root a. So with that you can say square root x can be approximated by tangent line at a, which is 1 over 2 square root a x minus a plus square root a. And to approximate square root x, you must find a number a near to x, such as square root a can be worked out easily. So if you want to approximate square root 2, you can choose 1.96 as your a, because 1.4 square is 1.96. So you use a as 1.96. There's a typo in the notes. So with that, you just sub a as 1.96 into the equation of tangent line here. So that's why it's 2 times square root of a, which is 1.4. You're choosing a as 1.96. So a is 1.96. And we get is 1.414, which is a good approximation to square root of 2. You can use a calculator to work out square root of 2 and see it's actually very near. If you want to approximate square root 3, then you can choose a number near to 3, which is something easy to work out, or like a perfect square in decimal. So 2.89, which is 1.7 square, is near to 3, because 2.89 into 3. So you choose A as 2.89, and then you sub A as 2.89 into this equation, this approximation. You will find the square root 3 gives you 1.732. It's also a good approximation. You can key in the calculator and work out square root 3. You will find that it's a good approximation. So how about square root 23? You will find that 23.04, which is 4.8 square, will be a good number to choose. So just sub A as 23.04 into this equation, and you can approximate square root 23, which will give you 4.796.